All right, hello everyone. Today's video is for MAT0022, and this is Module 2A Notes. This deals with the homework, and in this section, you're working with numbers, prime numbers, comparing numbers, and simplifying numbers. We'll begin with number one and we'll continue with the rest of the highlighted problem. Starting with number one, select the correct choice that completes the sentence below. A natural number that has exactly two factors, one and itself. Now, which of these answers would it be? Composite numbers or prime numbers? And the answer is prime numbers. The definition of prime numbers are not numbers that can only be divided by themselves and one. So prime numbers can only be divided by themselves and one. Can only be divided evenly by themselves and one. So they only have two factors. The prime numbers can only be divided by one and itself. So whatever the number is, if the number is 5, 5 can only be divided by 1 and by 5. So we'll fill in this space with the word prime. For number one, all right, we'll move on to number three. Number three, we want to find the prime factorization of 42. Now, here we are with 42. We're going to make what's called a factor tree, and we're going to write two lines underneath 42, and right beneath those lines, we're going to list two factors of 42. But when I say two factors, I'm talking about two numbers that can be divided evenly into 42. And two numbers that can be divided evenly into 42 are 7 and 6. And also 7 times 6 gives you 42. So that will be a set of factors. Now the goal is to stop when you have prime numbers on either of these branches. On our branch to the left, we have 7, and 7 is a prime number. We'll go ahead and circle 7. That will be a part of our prime factorization. So I'm going to go ahead and write 7 down here at the bottom. Now 6 is not prime because I can divide more than just 6 and 1 into 6. I can also divide 2 into 6. And 2 times 3 gives us 6. So those will be two factors of 6. Now we'll stop because 2 is prime and 3 is prime, and we're done with the factorization. So the prime factorization of 42 would be the 7, the 2, and the 3. So you would simply write 7 times 2 times 3. Now let's look at number 5. Identify the numerator and denominator. The numerator of a fraction is your top number. I'm going to put n next to 5. The numerator is going to be 5. The denominator is the bottom number of a fraction, and in our case, 4 is the bottom number. That's our denominator. Is this fraction proper or improper? This fraction is improper. The reason why it's improper is because the numerator is larger than the denominator. So we'll remember those rules. Improper means the numerator is larger than the denominator. And then, of course, proper fractions will be the opposite. Proper fractions is when the numerator is smaller than the denominator. So we're writing definition for improper. Numerator is larger than the denominator. The numerator larger than the denominator. I'm going to have space to write the whole word. So denominator. The numerator larger than the denominator. And then proper fraction is when your numerator is smaller than the denominator. All right, let's move on to number 8. For number 8, you're asked to change this mixed number to an improper fraction. And the steps we take to get our improper fraction, I'm going to draw a line because what we're going to create is a fraction. First of all, our denominator stays the same. So see how our denominator is 4, we will keep 4 in the denominator. To get our numerator, what we do is we multiply the whole number times the denominator. So I'm going to put that in parentheses, 6 times 4. And then we add the numerator. Our numerator is 1. All right, so 6 times 4, or the whole number times the denominator, plus the numerator. All right, so 6 times 4 gives us 24 in the numerator, plus the 1 makes our numerator 25. And remember, the denominator stays the same. So it'll be 25 divided by 4. And we'll keep the fraction as 25 divided by 4. All right, moving on to number 12. For problem number 12, it asks you to write this improper fraction as a mixed number. So now we're going backward. Look at our improper fraction. It's 243 divided by 9. And we have to divide in order to change this to a mixed number. So remember, the bottom number goes outside of your division bar. 243 in this case will go inside, and then we'll begin dividing. 9 divided into 2, we can't make that happen because 2 is too small. But can 9 be divided into 24? It can. How many times can 9 go into 24 without going over? Will be 2 times. 2 times 9 gives us 18. We want to subtract. 4 minus 8, we can't subtract 4 minus 8, so we have to borrow from our 2, making this a 1, making our 4 a 14. And then 14 minus 8 gives us 6. Carry down our 3. Now 9 can be divided into 63. It can be divided evenly 7 times. All right, so here's our answer, 27. That will be an improper fraction as a mixed number or a whole number. In this case, it became a whole number. Now let's look at number 13. Write this fraction in lowest terms. 4 divided by 12. To write this fraction in lowest terms, we have to find what's called the greatest common factor, the GCF. We want to find the biggest number that can be divided evenly into 4 and 12. We know that 2 can go into both of these numbers because they're both even, but there's a larger number that we can divide into both of them, and that is 4. We can also divide the top and the bottom by 4. Now remember, whatever you divide in the numerator, you must also divide in the denominator. So 4 divided by 4 gives us 1 in the numerator. 12 divided by 4 gives us 3 in the denominator, and 1/3 is our answer. All right, let's look at number 16. And for number 16, you have a word problem. It says a work shift for an employee at a restaurant consists of 10 hours. What fraction of the employee's work shift is represented by 8 hours? So his shift consists of a total of 10 hours. That total, that 10 hours, should be in your denominator. Now we want to know what portion of the 10 hours does 8 represent. So 8 would be in the numerator. We want to know how much of 8 is 10. So 8 out of 10 is your correct fraction. But remember, when you're working with these problems, you must always simplify or put your fraction in lowest terms. Therefore, we'll look at 8 and 10 and find the GCF again. You need to find the biggest number that can be divided evenly into 8 and 10. Again, 2 can be divided into both. Is there a bigger number? 4 can go into 8, but it can't go into 10. So we'll stop with the 2. Divide both the top and the bottom by 2. 8 divided by 2 in the numerator gives us 4. 10 divided by 2 in the denominator gives us 5. So 4/5. What is represented by 8 hours is 4/5 of her shift. or of the employee shift. All right, now number 18, this is the last problem we'll do. To determine whether the pair of fractions are equivalent, we're going to cross multiply. Now I'm circling the terms that are directly diagonal to each other, and those are the terms we're going to multiply. What we're checking for is to see if when we multiply 7 times 12, do we get the same multiple that we get when we multiply 6 times 14? So you'll just multiply the terms that are diagonal to each other, and I'm putting a question mark here because we're checking to see if those two numbers are equivalent. If they are equal to each other, then we'd say yes, these fractions are equivalent. If they are not equal to each other, we'd say no. All right, so 7 times 12 gives us 84. And again, we're checking to see if that equals 6 times 14. 6 times 14 also gives us 84. So yes, these two fractions are equivalent. So we choose the second one. And that's the end of the module 2A notes. We'll stop here.